Hello. So for a complete graphing of the tangent and cotangent functions, if we have y equals a times tangent b times x minus c plus d, or if you had cotangent instead of tangent. So with these, just like sine and cosine, a is your amplitude, c is your horizontal phase shift. Remember, this is an additive inverse for your phase shift. D is your vertical shift. This will rise your whole graph up, or it will lower your graph. The difference with tangent and cotangent is the period will be your your pi over b. So for sine, cosine, secant, and cosecant, the period is 2 pi over b. But in tangent and cotangent, the period is just pi over b. So here we have this situation. Here our b is pi. This is the same thing as y equals 2 sine of pi x divided by cosine of pi x, because tangent is sine over cosine. To find out what your period is, so the period is going to be pi over b, but in this case, it's pi over pi, so the period is going to be 1. So we can label our horizontal axis with whatever marks we want, but it's easier to coincide it with your period. And so this one, I'm going to mark this as period is 1. I'm going to have 1/2, 1, 1.5, 2, and then let's go -1/2 and -1. Okay, now our amplitude is 2. I know the orange doesn't show up well, but for consistency, so let's take a look at your asymptotes. So your asymptotes are where the graph does not cross. It happens when your denominator is 0. Notice that when x is, so one of what we want to look at is pi over 2 is equal to pi x, because cosine of pi over 2 is 0. Okay, if we multiply this by 1 over pi, what we have is x equals 1/2. Okay, so when x equals 1/2, that's our asymptote. That's one of the asymptotes. And this has a period of 1, and so this will also be an asymptote. Or when you plug in 3/2 for x, you get cosine of 3 pi over 2. Cosine of 3 pi over 2 is 0. You cannot have 0 in the denominator. Okay, and also this is an asymptote. Now, when the numerator is 0, this happens when x is 0, when x is 1, when x is 2. So this will go through the origin. Because when x is 0, sine of 0 is 0. When x is 1, sine of pi is 1. When x is 0, sine of 0 is 0. When x is 1, sine of pi is 0. 0 over non-zero is 0. When x is 2, sine of 2 pi is 0. 0 times 2 is 0. 0 divided by non-zero is 0. So these are where it crosses the horizontal axis. if we look at these midpoints, and you may see that this is 1/4, this is 3/4, this is 5/4. So when x is 1/4, we have sine of pi over 4. That's radical 2 over 2. We can even go back to here. Tangent. Tangent of when x is 1/4, tangent of pi over 4 is 1. 1 times 2 is 2. And so whereas in the previous graph, an amplitude, if you may, is 1, because this is a 1. What's going on down here? This is a 2 and a -2. And then this graph is going to it's supposed to be a curvy line. Okay. This has the same shape as a tangent graph, but because your A is 2, it's going to stretch it. If your A is between 0 and 1, it's going to make it more fatter. If this were an A of like 1 over 10, it would look more like y equals x cubed. That's not the case here. Okay. So again, it's going to go up to the 2 point. It's going to go down to the -2 point. So when I grade the graphs of the tangents, I'm not looking for complete computer precision. Oh, that is just terrible. I'm not looking for computer precision with your drawings. As you can tell, I'm having a hard time drawing them myself. But I would know if you're graphing something like a tangent versus a parabola. These are definitely not parabolas. Okay. This is going to look just like the one before, except this will be reflexive. So you're going to have your same asymptotes, or you're going to have the same period, same asymptotes. Here our period is going to be 1. So because our period is 1, let's make this 1/2, 1, 3/2, 2, -1/2, -1. When is your denominator equal to 0? When x is when x is 1/2. All of this is pi over 2. So when x is 1/2, there's an asymptote. Since your period is 1, there's an asymptote. There's an asymptote. So since I can scale this vertical line however I like, so let's make this a 2 and a -2. And then this would give us the same shape as what we did earlier. This also goes through here, here, and here. And here, and here. Oh, I did those completely backwards. It's got a negative in front there. So it will actually pass in this direction. Okay. So here our period So here a period is equal to pi over b, and this implies that our period is equal to pi over 2 pi, which is 1/2. Okay, and this is the same thing as okay. When is that denominator equal to 0? Well, that's going to be when we have multiples of pi over 2. Pi simplify out. So it looks like we have when our x is equal to 1/4. So when x is 1/4, 1/4 times 2 pi is pi over 2. Cosine of pi over 2 is 0. That's where you have your asymptotes. Since this period repeats every half unit, this will repeat every half unit. Okay. The numerator when x is 0, sine of 0 is 0. And then when x is 1/2, period is 1/2. When x is 1/2, sine of pi is 0. Okay, so we're looking at 0, it crosses the axis, and every 1/2 unit is the period. This is negative, so it's going to start, well, not start, but going to have endpoint behavior looking like this. And since our a is 1/2, let's do this to it. So since our a is 1/2, let's go positive 1/2 and negative 1/2. Let me do different colors for the contrast. Okay. That should be enough. Yep. All right. Now cotangent is a little bit different. What cotangent is, So cotangent is going to be, this is y is equal to cosine of 2 pi x divided by sine of 2 pi x. And here the period is going to be pi over b. So this implies that the period is going to be pi over, well here b is 2 pi, and so p is equal to 1/2. Our period is 1/2. Okay, so that's going to tell me where I draw these marks. So period is 1/2. Let's go with 1/4, 2/4, 3/4, 4/4, and -1/4 and -2/4. Looking at the A is 1. So let's make this and let's go for the asymptotes. So we want when we're looking for when 2 pi x equals 0, because sine of 0 is 0. It tells us that x is 0. At x is 0, we have an asymptote. And every half unit away from that, we have an asymptote. So that's an asymptote, even though it doesn't look like it. And our period is 1/2, so it's going to repeat every half unit. There's an asymptote, and there's an asymptote. And here. It's going to cross the axis when the numerator, and so the numerator, this we're looking for, we want 2 pi x equal pi over 2, because when this is pi over 2, cosine of pi over 2 is 0. Okay, so we can multiply both sides by 1 over 2 pi, and this tells us that x equals 1/4. One-fourth times 2 pi is pi over 2. Cosine of pi over 2 is 0. So x equals 1/4. This will cross the axis and every half unit away from that. How about at the 1/8 mark? Okay, so at the 1/8 mark, what are we doing? Well, if we have, so 1/8 times 2 is 1/4, it's cosine of pi over 4. Which is a positive 1. How about at the 3/8 mark? What's going on? So 3/8 times 2 is 3/4. So what's cosine of 3 pi over 4? And then sine of 3 pi over 4. This implies that y is equal to, well, that's going to be a -1. So that this point is down here. You cannot cross this asymptote, so it's going to go in this direction. Okay, notice the difference between cotangent and tangent. Your basic tangent, the difference between your tangent and your cotangent is that it is shifted and it's reflexive. Okay. Thank you very much. Please go to tutoring.